Hi everybody and welcome. Today we're going to be looking at proportional triangles and some of the properties of those triangles. So your goal after watching this video will be able to correctly identify and apply the triangle midsegment theorem and also be able to correctly identify and apply the triangle proportionality theorem as well. A fun example of this, and I'm sure you've probably seen this come up a couple of times online, is you see an image of something, you order it, and then it comes in and is drastically not what you expected. So this person ordered a Converse backpack. They thought that they were getting a full-size backpack for themselves, and turns out it is honestly a little bit too small for their cat. I think I've seen the same thing with like sectional sofas before. It's like a really small sofa that was delivered and stuff like that. So an example is that obviously this backpack is functional and does match the larger backpack in every way except for its size. So again, really hammering home that idea that we are the same shape. Everything is proportionally the same. It's just kind of scaled up and scaled down of the same different type of model here. So with that being said, we're going to get started off with first the triangle proportionality theorem. So this is just saying that if a line is parallel to one side of a triangle and intersects the other two sides at two distinct points, then it separates these sides of segments into segments of proportional length. Basically what it's saying is if you have a triangle and then you put a parallel line in here, so these two guys here are parallel, you actually form two new triangles that are proportional. So looking into this, and we can highlight it, here is the new triangle that we formed, and then the OG triangle, the original triangle here, goes around the outside like that. So they're proportional to each other, their lengths are in proportion, and if they're parallel, you can say that they're proportional, and if they're proportional, you can say that they're parallel. So let's look at an example of this here. They're telling us that RT and VU are parallel. We know that SV equals 3 and VR equals 8. UT equals 12, and they want us to solve for X. So our baby triangle, we have 3 over X. And for our larger triangle, so again, that's the baby triangle there. For the larger triangle on top, we have 11 because it's both of these side lengths together. And let me highlight that. So it's 8 and 3 together. And on the bottom, we're going to have 12 and X together. So just like we've been doing, we're still going to cross multiply here. And I'll show us the two different ones that we're doing. So in green, we have 11X, and then in blue, we have 3 times 12 plus X. Distribute that in, 36 plus 3X, and then on the other side, we still have 11X. So we just go through and solve this like we would for normal algebra here. So we'll finish this one up, minus 3 from both sides. Got 8X, got 36, divide those out by 8, and our final answer is X equals 4.5. Well, that's how you'd solve a question like that. And again, the idea is setting up and using your knowledge of proportions. Secondly, the converse of this, or it just basically means the opposite of it, is the converse of the triangle proportionality theorem. So if a line intersects two sides of a triangle and separates the sides into corresponding segments of proportional length, then that line is parallel. So it's basically saying in this same example of a triangle, if you have a line like this and you know that it's proportional, then you can also say that it's parallel. So if you can prove it's proportional, then you can also say it is parallel. And it actually goes both ways. So that's the idea of these two theorems. And again, that means parallel here. It's a symbol for parallel. So let's do another example of this. So in DEF, we have DH equals 18, HE equals 36, and they're saying that DG is half of DGF. So DG here, they're saying is 1/2 of the length here. So like half of X, for example. So let's see if it's proportional. So if we put 36 over 18, is that the same thing as 1 over half? Well, if we do our cross multiplication, let's see. So 36 times 1/2 is 18. 18 times 1 is 18. So yes, we can say that they are proportional. Because they are proportional, they're parallel. And that's what we can say from above. So prove it's proportional, tells us that it's parallel. or if we know that it's parallel, it proves that it's proportional. Works both ways. That's the theorem that we're using. So if you're doing this in a proof, to prove example number 2, that would be the converse of that triangle proportionality theorem. All right, last example here today, triangle midsegment theorem. So this is a little bit different. It's telling us that the midsegment of the triangle is parallel to one of the sides, so similar to what we saw before, and its length is exactly half the length of that side. So in this triangle here, if we made a parallel line, it's going to exactly go halfway through here. And what this is telling us is that this side is equal to that, and that segment is also equal to that segment. So it kind of splits it up into equal parts. So we're going to apply that to example 3. They're saying that OA is a mid-segment, so that means that this and this are equal, and it also means that this and this are equal. And that's going to allow us to solve. And that's going to be your job to finish up the video today, is set each of these things equal to each other and get an answer for y equals. And you're going to want to do the same thing here. I'll do it in a different color for your x's. And again, go through, solve, get x equals. So again, finish up this question. Make sure you're submitting pictures of your notes and work. That way I can document it and give you credit for it, of course. If you have any questions, let us know. You can either book an appointment in Google Classroom. You can send an email, remind message, any of those things. We are here to support. And again, thank you everybody for your hard work. I will see you all in Teams very soon.